to study our interface to space. That's where the upper atmosphere segues into the lowest levels of space. I am Karen Fox. I'm here today at NASA's Goddard Space Flight Center in Greenbelt, Maryland. We are 20 minutes away from the launch. We're going to show you live coverage from French Guiana of that coming up. But in the meantime, we're going to tell you a little bit of information about the launch. We have, to tell you a little bit more about it today, 3 guests. We have Peg Luce, who is the acting director for the Heliophysics division at NASA headquarters in Washington, D.C. We have sitting next to her Willis Jenkins. He is the program executive for the Explorers program, also at NASA headquarters. And our third guest today is Sarah Jones. Sarah Jones is the mission scientist for GOLD right here at NASA Goddard. So really excited to tell you a little bit more about this mission. We're going to start nice and simple. Sarah, tell us, what is GOLD going to do? What is it going to be studying?
Sure. Well, the GOLD mission stands for Global Scale Observations of the Limb and Disk, and it's a camera that takes pictures of the upper atmosphere, which is the boundary between the Earth and space. The GOLD camera will be at geostationary orbit, which means that it will hover 22,000 miles above the Earth, looking down on the upper atmosphere and seeing what's happening below. The way this camera works is that it takes a picture of a small portion of the Earth and then moves over and takes another picture, moves over and takes another picture, and so on as it scans across the Earth in one direction and then back in the other, building up a full mosaic image of the upper atmosphere across the Americas. And GOLD does this in 30 minutes time, which is much faster than we've been able to do before. We have had similar cameras fly on satellites before, satellites in low Earth orbit and other orbits that are not stationary with respect to the Earth. And in this case, the camera is zipping around the Earth, and that actually makes it take longer to build up these global scale images. It takes days or longer. So the information GOLD is giving us is important because the atmosphere is really active. We can get significant changes on a time scale of an hour. And GOLD, with an image every 30 minutes, will allow us to see some of those faster changes that we were never able to see before. Now, GOLD, as it looks down, is not imaging the surface of the Earth. It's imaging the upper atmosphere. And in particular, it's imaging the glow that comes from the atmosphere, which scientists call air glow. Now, this air glow is caused when the sun's radiation comes down and hits the particles in the Earth's upper atmosphere and causes them to give off light in a variety of colors. GOLD in particular is measuring far ultraviolet light, which is invisible to the human eye, but this information can allow scientists to determine the composition and temperature of the atmosphere, and in particular being able to have a global scale temperature map across the whole Western Hemisphere. This temperature of the upper atmosphere, which we've never had before on a global scale, will really help scientists in our data analysis. Without this information, it's much more difficult. Just imagine trying to figure out what the temperature is in California when you only have a temperature measurement from New York City.
Okay, so you have just described for us how GOLD is going to get better information on this upper atmosphere than we've ever been able to do before. But why do we care? What's interesting about this region? Why does NASA want to study it?
Well, certainly, Karen, we care about this region of the upper atmosphere because there's a lot of fundamental science that we still have to learn. But also, the region of the upper atmosphere is very important to our daily lives. In fact, our satellite communication signals, our GPS signals, signals that are coming down to our cell phones have to pass through this region as they're sent down to our technology on the Earth. As we talk about the upper atmosphere that GOLD is measuring, we're talking about the region that starts 60 miles above us and extends upward. Most of the particles in this area are neutral. They're not charged particles. They're essentially an extension of the air that we breathe down here below. But there is a small component that's created when the sun's radiation hits those uncharged particles of the upper atmosphere and breaks them up into ions and electrons, creating small numbers of charged particles. And this new component is called the ionosphere. Now, the GOLD mission is designed to measure both the neutral particles and the ionosphere. And in particular, when it comes to our technologies, the ionosphere really has an effect on the way radio signals propagate, for example, from our satellites down to our technologies below, and the ionosphere is affected by changes that are happening in the sun's radiation as it comes to the upper atmosphere and other types of space weather that impact the ionosphere from above. At the same time, this region is also affected from below by weather type effects like we experience down here on the ground. For example, tsunamis can create waves in the air that then move upwards and can even reach the upper atmosphere and could even make changes in this boundary between Earth and space. And so this creates a lot of structure in the ionosphere, and when the ionosphere becomes more structured, it can actually garble those signals that are coming from our satellites down to our technologies. And then it has a big impact on our daily lives. So the GOLD mission is designed to try and sort out the influences of the various effects from above, the space weather, and the effects from below, in part the terrestrial weather that we experience here below.
Thank you so much, Sarah. We're all really looking forward to what GOLD is going to be able to do. We're going to expect science from it in about 8 months. In the meantime, it's about to launch. We are going to be having live coverage of that coming up shortly. It doesn't take just a few people to get one of these satellites up into space. We have a lot of people working together. The GOLD mission is led by the University of Central Florida in Orlando. The instrument itself was built at the University of Colorado's Laboratory for Atmospheric and Space Physics. And the instrument, this is an interesting mission, the instrument is what's called a hosted payload. It's going up on an unrelated satellite. In this case, that's a commercial satellite. It's SES-14, which is a telecommunications satellite run by SES out of Luxembourg. That was built by Airbus, and Arianespace is going to be getting it up into space for us with a launch that will be coming up live from French Guiana very shortly. So let's talk a little bit more about GOLD and how it fits into the larger NASA picture. GOLD is what we call an explorer. That's a certain class of mission. And here to tell us a little bit more is Willis Jenkins with the Explorers program.
Thanks, Karen. The Explorer program provides frequent flights for science activities and at a low cost. And what happens is that that's within the heliophysics and the astrophysics science area. Now, I would tell you that Explorers is the oldest program at NASA. It started with the first launch of Explorer 1, January 31st, 1958. And with that, we've had 100 successful missions. We will be celebrating the 60th year anniversary just next week. And that is just so exciting for all of us here at NASA. I will tell you also that we've had many achievements in the NASA with the Explorers program, and one is for it to have the first mission to be able to have scientists receive a Nobel Prize in physics. Sorry about that, and also to have 5 spacecrafts to launch on a single rocket. And that's just been so exciting for us. And I tell you that GOLD will enter in that overall experience and excitement that we have.
So we have this history of the Explorer program of really doing creative missions and pushing the envelope. And GOLD's an example of that too, right, with this hosted payload? Yes.
GOLD had tough competition in being selected. And so this becomes it's an instrument, and it's on a platform in which the GOLD instrument will receive. The GOLD instrument will receive telemetry, space, and it will also receive power, and that will come down. The exciting part about GOLD is that because it is not only just hosted, but it's on this communication satellite, which is the first time we've done it in Explorers. So we're real happy about that. The other thing about GOLD to remember, it's about the size of a small refrigerator, a mini refrigerator, but it's the weight of about 80 pounds. So if you could take 2 mini refrigerators and lift them up very carefully, I wouldn't suggest that. But it would be that in terms of a visual.
Great. So we've just learned a little bit more about gold and its position within NASA's spacecraft. It is also what we call a heliophysics mission. And we have with us today the acting director for the heliophysics division at NASA headquarters. And Peg, tell us a little bit more. What is this area of research that NASA cares about, and how does gold fit into this larger plan?
One of NASA's roles is to understand the very space around us and the effect of the sun on that space. And the field of heliophysics is a field of study in which we look at the sun, which is constantly changing, the ways in which it influences the Earth and the entire solar system and even space beyond the solar system. We like to say that space is not empty. It is filled with charged particles and radiation. Those particles are influenced by magnetic fields, electrical fields, and the variability in this entire system influences us here on Earth. As Sarah mentioned, space weather can affect our technologies, and in our society today we are more vulnerable than ever before to the potential effects of strong space solar storms that are directed in a way such that they can reach us. So in heliophysics, we want to understand the physics of the sun, as well as the ways in which it drives and impacts what's happening here on Earth. Because this is such a vast interconnected system, NASA has deployed a fleet of spacecraft that we call the Heliophysics System Observatory. It requires measurements in many, many vantage points, and there's a picture here of some of the spacecraft in our observatory. We are looking at magnetic fields, we're looking at the sun, we are sampling the solar wind, and as with gold, we are looking at the influence of those effects on Earth. So we want to investigate both what's happening all the way to the edge of space. We have the Voyager spacecraft there, as well as the near-Earth effects.
So you're talking about this vast system, and gold's going to add to that. What does gold bring to the table? You obviously are looking at this from all different perspectives. What can gold do to enhance those?
So what's really exciting about gold is its vantage point perched on a telecommunications satellite in geostationary orbit. So geostationary orbit is a unique orbit. It is one that communications companies have been sending satellites to now regularly, but it's a difficult and expensive place to get to. So the fact that we have been able to we are able to deploy a science instrument to that location, thanks to the creative idea of the principal investigator, Richard Eastis, for gold, who partnered with SES many years ago, wrote a proposal, and was selected to fly this mission. We are able to put an instrument up there that can look at the upper atmosphere. The principal investigator, Richard Eastis, Sarah talked about the interface with space, and see the disk, the full disk of the sun, or of the Earth, and as it's affected by the sun. This is really like revolutionizing our ability to understand the influences of the sun the way that terrestrial weather was influenced by our first weather satellites. So it's a very exciting opportunity for us and unique.
And gold is but the first of the heliophysics launches this year. Can you tell us a little bit more about how this fits in, all this grand picture that you're talking about?
Yes. So this is an extremely exciting year for us, and it's a bit serendipitous that we have 3 missions that are being launched within 2018. 2 explorers, Gold and ICON, which is the Ionospheric Connection Explorer, are both going to be looking at the same region of the atmosphere, the ionosphere and the upper atmosphere. But ICON has a very different approach and is very complementary to Gold. ICON flies in low Earth orbit. It directly samples the atmosphere that Gold is looking at from its broad perspective. And so together, these 2 missions will give us an extremely powerful new view of what is happening right in our neighborhood as a result of influences from the sun. In addition, we are extending our Heliophysics System Observatory all the way to the sun. So we're also looking at the origin of the solar wind, and with a mission called Parker Solar Probe that is going to be launched in July of this year. Parker Solar Probe is the first mission to fly to a star. It will actually enter the sun's corona and help us to study the particles, the way they're accelerated, the way the corona is heated, and really solve some mysteries that you can't understand by just viewing from a distance, which is all we've been able to do so far. The exciting thing about Parker is that it was first envisioned 60 years ago at the same time that the first Explorer was launched. But it's not until now that we've been able to develop the technology, a carbon composite shield that will allow the spacecraft to survive the 2,500 degree temperatures and the radiation environment that will be experienced. So again, we are fortunate this year to be extending our observatory from the very origin of the solar wind all the way down to the getting an intimate look and a global weather view of what's happening as a result of that solar wind when it reaches the Earth.
Thank you so much, Peg. There's a lot going on here. It's very exciting. We have just another minute or two before we switch to our live coverage. So I want to just ask very quickly, you each get just a moment to tell us what excites you most about this mission. Sarah Jones.
Well, I know we're all very excited to get down this new data that we've never had before and start analyzing it. Now we'll be able to answer long-standing questions like how does space weather and how does terrestrial weather affect this boundary between Earth and space. Thank you. Willis?
As you can tell earlier, I was really excited. I couldn't even get my words together for so much excitement. But really, it's a lot of creativity, innovation that we'll have for our opportunities in the future. And so what's actually going on is the Earth Science Division is going to fly a mission called GeoCop and be working with SES for a similar activity that we have with GOLD.
Great. And Peg?
I'm excited about the first weather satellite to study the weather responses of the upper atmosphere to solar energy.
Fantastic. It is exciting, and the launch is about to happen, so we are going to go to our partners, SES and Arianespace, for their live coverage. Thank you so much for being here today. You can track the mission at nasa.gov/gold. Thanks for being here today.
Going into the upper stage. One of the last things you'll see before liftoff, so we just like to take it, point it out. Minute and a half to go till the first launch of the year for Arianespace. All the tests and the campaigns to ready the launcher and the satellites are over. Everything that has had to be done has been done. You're going to hear the DDO call up the 1 minute mark.
Attention pour moins à 0 moins 1 minute.
DDO calling out the final minute.
Top à 0 moins 1 minute.
So we are into the final 60 seconds. Give us a chance to say hello to our friends at SES in Luxembourg, our friends at Yasat Abu Dhabi, to the Airbus Defense and Space teams in Toulouse, to the orbital teams in Virginia, to our industrial partners, ESA and CNES, and to all of you following on the internet. We hope you're enjoying it. If you're not settled in, pull up a chair and enjoy. We're going to cut away, let you listen to the DDO, and he'll call out the final seconds.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top. Allumage moteur Vulcain. Allumage EAP, top décollage. La propulsion est nominale.
The DDO says all is normal, and you saw at 1920 local time, and right on time, Ariane 5 began her mission, lifting off from the ground here in French Guiana with a lot of fire, heading into the clouds with 2 new satellites.
La propulsion est nominale.
The 2 boosters are providing 90% of our thrust right now, propelling the launcher along her trajectory at an ever higher velocity.
Les paramètres de bord sont conformes à l'attendu.
773 tons at liftoff. And to get that sort of mass off the ground, you need a lot of push, and push we have. She's burning 5 tons of fuel per second, 2.5 tons per second in each booster. And the core stage is burning another 300 kilos of fuel per second. Fine shots of Ariane 5 rising into the sky. She looks just like a comet. Ariane 5 now following the program in the onboard computer, as the DDO says all is normal on board, which gives the orders including stage separations, which we'll soon see. We're in the first of 4 flight phases. We'll describe each in turn so you can follow Ariane as she heads east across the Atlantic. Right now, the first flight phase, the single first stage engine and the 2 boosters are burning. The boosters will each consume their 240 tons. In just over 2 minutes, in about 15 seconds, they will be extinguished, and you'll hear that from the DDO. This first flight phase using both cryogenics, very cold fuel, and storable propellant. Cryogenic propulsion offering certain advantages, reignitable, more precise performance. And we move to the animation. In just about 2 seconds, you'll see the booster separation confirmed by the DDO. They will fall 500 kilometers from the shore in a protected area. Nice shot of it there on the onboard camera. There's another booster on the port side, of course, out of camera range. On the bottom of your screen, on the left our altitude, on the right our speed. Speed we need for satellite separation, roughly 9 kilometers per second. That's 9,000 kilometers an hour. You see where we are, just over 2 kilometers an hour. We have a ways to go. So keep your eyes on the numbers, and when we near the region of 8-9 kilometers per second,
Le pilotage est calme.
you know we will be getting close to separation. We're getting close to separation of the fairing, which is next up. That's the pointed nose cone on the right of the composite. You can see the logos on the outside of the fairing placed there by the customers. That's something of a tradition. There's separation on time,
Lagage de la coiffe.
confirmed by the DDO. And on the onboard camera, you see there's another half which falls away again out of camera range on the starboard side. Revealing to the elements our first passenger, SES-14. That's the blue and gold box on the right. We can separate the fairing now because we're out of the dense layers of the atmosphere over 100 kilometers up. There's neither friction nor heating, which could disturb the passengers. We can also discard any dead weight to maximize the launcher's performance. Fairing, remember, weighs almost 2.5 tons, so we can get rid of it now. With its family of launch vehicles, Arianespace is the reference, providing launches of any mass to any orbit at any time. And Ariane 5, of course, the heavy lift launcher, the 2 other members of the family, Soyuz and Vega. Next up in our series of films, one on our first passenger, SES-14.
SES has been a very faithful customer of the Arianespace family of launch vehicles, with more than 40 satellites entrusted to Ariane or to Soyuz. Our launch contract was initially for SES-12. However, 6 months ago, SES decided to launch SES-14 instead of SES-12 on Ariane 5. We were able to accommodate this request in the short time left till launch, in spite of the particularities of SES-14, such as the need for a purging system up to liftoff for the NASA Gold payload on board SES-14. SES-14, built by Airbus Defence and Space in Toulouse, is the second spacecraft in the Eurostar 3000 EOR series to be launched. It will rely on its electrical propulsion system to reach its final orbit, as both satellites on this launch use electrical propulsion, and thanks to the performance available on the Ariane 5 vehicle, we have been able to optimize the delivery orbit and reducing the time needed for the satellite to reach GEO.
On the right, as the DDO says, all is normal, this SES-14. Under that, the black bell-shaped structure is what we call the Silda. That's the carrying structure. Underneath that is our second passenger. We're in the second powered flight phase, the single-engine core stage burning now, the boosters having done their work. All of Ariane's trajectory has been designed to be followed from the ground. The launcher is sending radar and telemetry back, and a network of stations keeps constant watch on the health of all her systems. We'll start receiving that information in just a moment. Telemetry is launch vehicle data, information on 1,500 parameters being collected and transmitted back to the ground. We had a look at our first passenger, now a first look at our second customer, Alia 3. Now a first look at our second customer.
YASAT contracted the launch of Alia 3 satellite with Arianespace in September 2014. A year later, the mission analysis was initiated. The main objective was to consolidate the launch mission profile with the satellite-specific features. Alia 3 is manufactured by Orbital ATK and is based on the new Starfree platform. It is the first of its kind to be launched with Ariane 5. Throughout the years, YASAT has maintained regular exchanges between Orbital ATK and Arianespace to prepare the launch campaign and refine the launch mission. In summer 2016, Alia 3 was allocated the SES-14 as co-passenger. The overall mass of the two satellites remains well below Ariane 5 lift capability. To benefit from Ariane 5 full performance, a specific injection strategy is implemented for this launch. With Alia 3, YASAT will increase their in-orbit fleet to 3 satellites, thereby confirming their role as a global operator in government and commercial communications.
We will soon be picked up by our first downrange tracking station located in Natal over the border in Brazil. The Brazilian Defense Department runs the station for CNES in an agreement with the European Space Agency. It'll see the lower stage burnout and separation. And what do the ground stations like Natal do with all this information? Well, customers get immediate data on their spacecraft, and it's so important. Some data are analyzed in real time. Others are studied after the flight to learn how the vehicle performed on its mission. A complete analysis is carried out about a week after each launch. So you can imagine the enormous archives this gives Arianespace, a wealth of technical information going all the way back to the first launch of Ariane 1, 1979. We are awaiting confirmation of 3 events: extinction and separation of the lower stage, then ignition of the upper stage. That's due just in about 15 seconds.
Les paramètres propulsifs sont conformes à l'attendu.
Everything is all right on board, as the DDO says, the launcher performing flawlessly. Tonight, a standard double launch, 2 communication satellites. As we wait, there you see the cutoff of the lower stage. Separation of the lower stage. And
Séparation EPC.
Ignition of the upper stage. These 3 commands given by the onboard computer in about 13 seconds. So we are now into the third and final powered flight phase, the single upper stage engine that will burn until plus 24 minutes and 44 seconds, or 16 minutes roughly. The job of the upper stage is to take the satellites to their injection point, position them for separation, and then release them. That is its propulsion role. But she also has a second role, and that comes during Ariane 5's ballistics phase. That comes later on in the flight, and we'll have more on that coming up. You're looking at the people from the Alia 3. Alia 3 arrived here in French Guiana November 29th. Hi there. It went right to the satellite preparation buildings here at the CSG, known as S5 for its checks. SES-14 came about a month later, December 22nd, began its tests. All that preparation usually takes about a month. And you heard about it in the first film on the launch campaign. And we're going to go to another look now at our second passenger, Alya 3. Back with more of the mission in a moment.
Today is an incredibly proud day for Yahsat and the UAE as we have launched our third satellite, Alya 3. This achievement allows us to continue our dream of providing connectivity to the rest of the world and helping these parts make sustainable changes to their lives for the better. Yahsat celebrated its 10 years anniversary in 2017. Yahsat is proud to have customers in 55 countries around the world and to be providing DTH solutions to over 50 million viewers in the region. It gives us immense pride to be serving the Milsatcom's needs of the UAE Armed Forces as well as the government sector. Yahsat is also proud to be the leading satellite broadband provider in Africa today. Alya 3 is a Ka-band satellite dedicated to expanding our broadband services to 19 additional markets in Africa and marks our first entry into Latin America, specifically the Brazilian market. In few months, once fully operational, Alya 3 will enable Yahsat to empower 60% of the African continent's population and 95% of the population in Brazil.
We're going to look closer at Alya 3 in the next couple of films coming up. But before we do, I just want to make another point on the propulsion systems on Ariane 5, which is so interesting, using both cryogenics and solids. Cryogenics, as used in the main stage, as you saw, more efficient, basically, than solid propellant, which is used in the boosters. Basically, solids are for getting us off the ground, away from the pull of the Earth. Cryogenics, on the other hand, are for more precision orienting of the vehicle. And, of course, they allow the stage to be reignited, but that's in the other version of Ariane, not in the one being used tonight. One advantage on the other side of storable fuel is that